Ladies and gentlemen, this is Joe's Classic Video Games, back with another cool pinball repair for you this evening. Now, we have been slowly working through a lot of the pinball machines that we have in storage here at our shop. We're trying to clear out our front room over here. Let me show you a view of it. Got all kinds of stuff here. A lot of this stuff we've actually had here for quite a while. What happens is we get stuff in and we have it stored up here, and then people bring us stuff to repair. Like, for instance, this Grand Prix is a repair that we're doing for a customer. And some of our stuff gets kind of put on the back burner. That crane machine there is a repair. The Future Spy is a repair. This Galaga is a repair. But we've been slowly working through it, right? And we've finally gotten back to one of the things I've been wanting to work on for quite a while. And it's this cocktail pinball machine. This thing has been buried under a bunch of stuff for just quite a while now. I don't even remember the name of it. You know the name of it because it's in the title probably, because I'm going to figure it out here in a minute. But I don't even remember where we got this thing. I think we got it in a storage building. I've worked on a couple of these before, but I just don't see them as much anymore. If you've watched our channel long enough, though, you know that I kind of like the strange stuff like this. I don't really care too much about the stuff that's worth a bunch of money. I prefer the stuff that you just don't see that much. So, you get to see it with me. Vroom. Hearts and Spades. Allied's Hearts and Spades. It really just says Allied's Hearts Spades. Alright, so this is a cocktail pinball machine. You sit down to play it. And I remembered that it was in pretty decent shape. Most of them are. If we can get the top on it, we'll figure that out later. But we've never tried to plug it in or anything. I don't even know if the board's in it. But we're going to find out on this video. So this is our next little project. Like I said, I've worked on a couple of them before, and I used to have a whole box of boards for it. We sold one to somebody, and they, months later had some trouble out of it, and they were trying to find a board for it, and I told them, okay, well, I've got a whole box of boards, you can check them out. So I gave them like 7 boards or something in a box, and they never brought them back. So they stole all my parts boards. Shows you what happens when you try to be nice to somebody. So if the board is in it, we'll just have to fix it. I may have there were a couple different companies that made these. I can't remember how the boards even look, but we'll figure out here shortly. So it's just a game that you sit down and play, just like they had sit-down arcade games. They also had sit-down pinball machines. Big old coin door on it. Got a plunger here. And this was made by Allied Leisure. Maybe that's the start button. Flipper. Other flipper. It's so cool. All right, so let me take that top glass off of it, and then we'll look at the playfield a little bit. All right, we're missing a flipper. That's our first big problem. I don't like that. Some of this stuff for these cocktails is really easy to find because they made a bunch of extra parts and they're just all over the place. But I don't know if the flippers are. It might be a pain trying to find one of them, but maybe not. This is also one of those things where a lot of people don't appreciate them, so they've probably parted out tons of them over the years. So if I can't find a replacement flipper, if it's not inside of it, we can probably, hopefully, get one. They have put the tack sticker right on the playfield. Wish they wouldn't have done that. However, the playfield does look to be in pretty good shape. If you look here where the light's hitting it, right, that's in pretty nice shape. This should clean up pretty nice, and I should be able to get that tack sticker off. If it wasn't there, if they had put it on the glass, I'd probably leave it. But I mean, it's on the freaking playfield. So it says Allied's Hearts Spades. You've got the 2 flippers and the 2 slingshots. You've got a bonus ladder here in the middle. You've got 3 pop bumpers. You've got 2 drop targets above the pot bumpers. You've got 3 stand-up targets here on the left. 3 stand-up targets up there. A big stand-up target up there, and it says opens gate. What gate? Maybe the gate's in here. So it says collect hearts and close gate. Yeah, so not a ton going on. There's 2 targets behind the drop targets. And you know, the play field's about, it's actually a little wider than a traditional play field. But it's only, I don't know, 2/3 the length of it. And then you've got 2 little displays here. Who knows if those work? A credit display. And then it appears like some little LED lights. So, very cool. All right, let me see if I can figure out how to lift up the playfield, and we'll see what's inside of it. So the playfield just easily lifts, and it has a pivot on each side. And it has a kind of friction thing to hold it in place on the bottom. So there's just a piece of metal there, like almost like a spring bar. And when you push it, the bottom of the playfield just bends that out of the way, and friction holds it in place. Just like that. Very cool. So it's back just a little bit past 90. All right, so looking at the bottom of the playfield, we've got a wire gone here that appears to have went to here. Almost looks like that's just broken. Let me see here. Okay. Those are the drop targets. The stand-ups here. A lot of rollover switches here. This must be the gate that it was talking about. It's inside that little tunnel thing. And yeah, we're missing one flipper mech. I do not have that style flipper mech. So I'm going to look and see how hard that's going to be to get. Here's the date of the thing. February 6, 1979, Allied Leisure. Very cool. So there's a PCB, or several it looks like, up here for the displays. Down in the bottom, I'll show you the back of the coin door. Look at this, there's a bulb here that just illuminates the front of the coin door so you can know where to put your quarter. And then on one side there is, what are we looking at here? There's a coil just hanging there. Why would that just be hanging there? Yeah, this thing's been abused a little bit, folks. There's a chime mechanism. Flipper power relay. This is very different than how the other companies did theirs. A replay knocker. And 79, I don't know when they built the first ones. Of course, I could look all that up, but 79, you know, you were only a couple years into any of the companies doing electronic pinball machines. Here is the power supply. Got a big transformer down there, of course. But the power supply up here with 8 fuses. 7 of them have an LED on it, so I guess you can tell if they're blown or not. 3 bridge rectifiers. A couple filter caps. And then over here you have the actual game board. Now, what makes these a little easier to work on is they don't have a battery on them. So they didn't all rot away like a lot of them did. Also, the chips are all well, the 40-pin chips, at least, are all socketed, so that makes it a little easier. The chances that that thing's working correctly, though, very low. But hopefully we can fix it. Flipper mounted on the side of the cabinet. Flipper switch. Okay, so the very first thing I need to do, I'm going to go ahead and jump on trying to find that flipper mech. Let me see if I can find one on eBay or something and go ahead and get it coming. I just want to make sure that that's not unobtainium. You know, you just can't get it. Check out the ball kicker. And the regular kicker. A lot of play in them. Just a different way of doing it. Look at how those switches are. Just their own way of doing it. Look how they labeled where to put the wiring for the lamps and things. They even showed them where to put the staples. Pretty cool. I just like seeing stuff that you don't see all the time, you know. Okay, so we need to see if we can find schematics for it, because they're not in it. And we need to see if I can find a flipper for it. It looks like there might be a soundboard down there, too. Maybe. I would guesstimate that may possibly be a soundboard, or that might be a part of a power supply, too. So we'll figure that out. Yeah, cool. All right, well, that's where we're starting. All right, so on the Internet Pinball database, there is a file that's got the schematics for a bunch of the Allied Leisure games. There are actually several of them. It looks like there's about 10 different games they made. And they have slightly different setups depending on when they were made, it appears. So this one appears to match what I've got in my machine. I'll show it to you here in a second. They're calling it, what does that say? Pinball power supply, 30 watt. All right, so it's kind of hard to read. So we've got A3P6, it says here, cabinet power distribution. A3P7, backbox power distribution. A3P8, well, this can't be right. We don't have a backbox. And A3P5. So they've got 1, 2, 3, 4. Yeah, that's not correct. This half of it looks right. So they've got one connector, A3P3. That's one connector. A3P2, that's another connector. And A3P1. So 3 connectors on one side. One is coming from the transformer. One is coming from the regulated 5-volt power supply, so it's power going out to it and then coming back. And then one is handling the AC line coming in and the power switch going out. All right. So that appears to be what we've got here. We've got one set of wiring for the transformer. That's that plug. We've got one set of wiring for the 5-volt power supply. That's that plug. And then we've got one connector, one set of wiring for the power switch and the AC line coming in. Now on this particular one, we have 2 connections, a black one and a red one. Looks like there's one missing that's not populated. That's probably the one that was the back box one. It may be that is another one. Looks like it's 6 wires. Maybe that's the other one that we saw that we couldn't figure out. What does that say there? A3J5. Okay, and then let's see if we got one over here. A3J7. So 5 and 7 are missing. 6, and we can imagine that's 8. Yep. So we've got 6 and 8, 5 and 7 are missing. So there's 6. We've got that one. It says cabinet power distribution. 7 is missing on ours. This is backbox power distribution. If you look, it's just doubling off of stuff that goes to the other connectors. 8, we've got that one. It says playfield power distribution, because ours has a playfield. And then here's 5, the one that's missing. It says earth ground and earth ground distribution. So they must have just designed it where you don't need this in this particular model. So these are the correct schematics. It's just we don't have all of this. Now I looked for the flipper, and that's really hard to find. But you can replace them with Gottlieb flippers. You just put the whole assemblies on there. With that said, I think I've got 2 more of these in storage, so I can probably just grab a part off of one of them and then put new Gottlieb flippers on that one whenever I bring it in to work on it. So I think we'll be able to get the parts off of another machine I've got, or at least that's our hope. I'll check that out this weekend to make sure I've got them, and if I don't, we'll just upgrade the flippers. So all that to say, I think we're ready to start working through the power supply. So I'm going to pull that board out of the machine, and then we'll look at it on the desk. And I just want to check some of the things on it, test the bridge rectifiers, test the fuses, things like that, and to make sure that everything seems fine before we try to power this thing up and burn up the MPU. So here's that power board that we were just looking at. There's the back box connector, is not populated, but if you look, this connection just goes to here. Now, I don't know if that, let me see if that goes anywhere else. That's there. Yeah, so it connects to that plane, which runs up to the other ones. So this connection is mirrored onto the other ones. This connection as well. 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 So it's just a way for them to send power to the back box, to the playfield, to the cabinet. And since this game doesn't have a back box, it just literally doesn't need that connector. The one over here is extra grounds. They must have figured out a way to put the grounds on the other ones. But these boards are so cool. It's just stuff from the 70s. It was how they originally did it. Everything's oversized. There's plenty of room. Big old fat traces everywhere. You can easily tell where something goes. You don't really even need a schematic, although it helps you figure out, you know. So since there's like nothing here, it's going to be really easy to work on. So we've got a resistor here that looks a little smoky. Might have to replace it. We've got 2 disc capacitors here, and if I don't break them by playing with them, they should be fine. Right? And then we've got a varistor there that's not burned up yet, so that's cool. And then we've got 2 capacitors. The big filter capacitor I'm just going to leave. I don't think that will be a problem. It's an 8,000 microfarad 40 working voltage DC capacitor. And then this little 2200 UF 16 volt, I don't think I've got a radial one though. I mean an axial one. I'll see if I've got an axial one of those. Maybe we can swap it too. Or maybe, you know, you could get cutesy with it. The ground is going here, which is also right there. So you could drill a hole through there and mount it right there. But why reinvent the wheel? I wonder if we can get to it. Yeah, radial would be better. So there's really not much to repair, you know. The LEDs may be burnt out, but you probably wouldn't even need them unless they're designed where the power runs through them, which I doubt they are. Doesn't look like it. And we could test fuses. That should help us understand if something's screwed up, you know. And then we need to test the bridge rectifier. So it's all so simple to work on. It's really fun. Now I was looking through my stash, and I do have a couple parts boards that I picked up since that guy stole my other 8. So this one's in, well, they're both in kind of rough shape. They're old, folks. Let's see if we can tell what game they are. I don't believe we can because I don't believe they have a ROM. I think they just work off of the chips that they, you know, that are here on them. I don't think they have a code that they run. Pinball control computer. So if you think about it, if you design a pinball machine, if it's simple like these are, you don't need different code for each machine. They've all got a display. They've all got dip switches. In this particular instance, they didn't use dip switches. They used these little jumpers. Look at this mess. You move the wire to what pin you want on. Works perfect. Nothing wrong with that. So all the settings can work with that. It probably doesn't have any kind of bookkeeping mode or anything. And then the rest of it is, if this switch is hit, you get 100 points. You know, if this switch is hit, you get 10 points. If this switch is hit, you get 1,000 points. If you're redesigning a new game, all you got to do is just move the wire that is a 10-point switch over to wherever you've got a 10-point switch on the new playfield. You can rearrange everything and make it look completely different. And a drop target, you know, is very similar to just a regular switch. When the target goes down, it hits a switch. So they just move things around the playfield. So even if it's not even exactly like the playfield before it, the scoring's probably the same, or it could be the same. And it's just really simple to make several of them that use the exact same board and with no different code. So that's kind of what they were doing at first. And I would imagine these were probably much cheaper than the full-size machines. So anyway, I'm going to work on this a little bit, and then we can put it back in, and we can test the voltages coming out of this before we ever plug in the MPU that's still in the game. These are both parts ones. And just see if anything gives us any sign of life at all. All right, so I'm testing the bridge rectifiers. The way you test a bridge rectifier is there is a positive pin, which is this one. See the little bump on this particular one? It's marked like that. They're different on each one, though. So there are 4 legs on the bridge rectifier, and there are basically 4 diodes inside this bridge rectifier. Right? So to test it, you put it on diode test, and you put where this positive pin is, you put the negative lead of your meter. And you check the positive lead to the other corners that are adjacent to it. This is the AC input, the AC input. So this is the positive lead. There's a little plus mark here, right? And so since that's the positive lead, you're going to put the ground on there, the black lead of your meter, and then measure the diode to the corner and then to that corner. And then you want to reverse it for the other. Since this is the negative DC connection point of the bridge rectifier, you put your positive lead there and then measure to the 2 corners. And that's how you measure the 4 diodes that are inside of the bridge rectifiers. Well, when I do that, so this is the positive corner. Which is, did I lose it already? Nope, I got it. I got it. Positive's right there. Trying to make sure y'all can see it. You know what? We're finally to the point that this is going to work. Check this out. This was given to us as a gift. Well, if I can get to it. Okay. Positive corner. So we're going to put our negative lead on there and test it to the other corner. And so we're getting 0.485. That's between 0.4 and 0.6, which tells you that there's a voltage drop connection there. It's a gate, basically. It's a diode. So that's correct. And now if that was like 0.2 for just a rectifying diode, it'd be, you know, more like it's shorted. If it was above like 0.7, it would be more like it's open. It's not good. So I'm going from the positive connection on the bridge rectifier to the adjacent corner, and I'm testing the diode between there by doing that. And then I'm going to do it the other way. So I just tested the diode between there. So if we jump over to like the one next to it, we can do the exact same. That's kind of tricky because you got to know where the legs are that are coming through the board, right? So this is the Got to make sure I got it right. Yes. This is the negative connection on the bridge rectifier. So I've swapped. So we're going to put our positive lead on that and then check to the adjacent legs. 0.4, 0.4. You see how that's working? Whoa. Deal with it, folks. Okay, so now if we go over here to this middle one, 0.4, nothing. So this is open. It's not connected at all. So that one of the legs might be broke. It's not this leg though, because that one and that one, that diode is fine. So we're checking this diode and it's fine. When we check this diode, there's no connection there. So this leg may be broke. Oh, you know what? We could tell by doing this. Yep, the leg's not broke. Everything's connected. It's just the diode that's in here, from here to here, is not working. It's open. So in other words, that bridge rectifier is bad. So the next thing we need to do is figure out how many amps that bridge rectifier is. They're all pretty much the same, but some of them are stronger than others. So we need to see how many amps are in that sucker. The amps aren't actually in it. It's just how they measure it, right? How many amps can it handle? So it says right on the side, 7844. So that's going to be the 44th week of 1978. Now we already saw that the build date of the machine appeared to be February of 79. So this was made, this bridge rectifier, which is a component on one of the boards, was made late in 78. So that all adds up, seems right. And then down below it says NBS 25-100L. That 25 is probably significant. That probably means that this is a 25 amp bridge rectifier. And it just kind of, once you mess with them a little bit, you can kind of tell by looking at them. It looked to me like it was between like a 20 and a 35. And remember, whenever they're older, they're a little bigger than the modern ones. So I'm going to guess that's a 25 amp bridge rectifier. I'm going to look on those schematics and see if it mentions it. If it doesn't, we're just going to go with that. And amperage-wise, if you go higher, you're fine. So if I've got a 30 or a 35 or something like that, we'll pop it in there. All right, so I replaced the 2200 microfarad capacitor. I replaced the bridge rectifier that was bad. That resistor is 820 ohms, and it still measures intolerance. I don't have one that's a 2 watt. I don't have a 2 watt to replace it with, so we're going to keep our eye on it, but we might have to order that. And this cap here also has puffed a little bit. These older ones, they would leak. It's leaking a little bit, so that cap I'm not thrilled with, but I don't have an 8000 or anything. You can go a little higher. I've got some 12,000s, but they're not 40 working volts. They're like 12 volts. 16 volts. So we might have to order that too. But I feel confident that we can at least, there's nothing crazy going on with this, so we can at least test it and see what our voltages are like. However, part of this power supply is that 5 volt power supply that's in there as well. So I'm going to put this back in the machine and I'm going to pull out that 5 volt so we can get a look at that too. Okay, so here's the little 5 volt power supply out of the bottom. You could replace this with just a modern switching power supply if you wanted, but I'm just going to rebuild this one. There's not much to it. Why not? I guess it would depend on what that capacitor is. 9,000 microfarad, 15 volts. So yeah, I've got something that'll work for that. Then we've got a couple little axials there. I'll have those. I've got all of those. Everything else looks fine. There's a voltage adjustment as well. And this IC, let's see what it is. This is similar to the Gottlieb setup in their early pins. It's a UA723. Have no clue what that is. And a 2N3053. Have no clue what that is. Now on the back we have a 3055 voltage regulator. Cool. I'm going to just operate under the assumption that the thing works fine and replace these 3 capacitors. I mean, I don't see any reason to change things that may be just fine. I mean, I'll test some diodes while I'm in there, but, you know, it's probably just fine. Okay, let me do that, and then we'll I think if we disconnect these two, that's your outputs of the 5 volt. Well, I don't know. Since we've already got the outputs of the power supply board unplugged, we can just plug this in and just test it while it's in circuit. The worst case is going to blow a fuse on the power supply board, which wouldn't be the end of the world. So, yeah, let me get rid of those 3 caps. Now, if you're not into electronics that much, or you're just getting started, why am I focusing on that? It's because these electrolytic caps are filled with a liquid, basically like a paste, and it dries out over the years. So once these get really old, these two here are more than likely no longer within spec. You can test them kind of if you've got the right equipment, but if you've got them to replace with, you might as well just go ahead and replace them. These bigger ones, a lot of times you can get away with it because they were just made better, some of them, but I mean, you know, a lot of that's just dirt, but if you've got them, it doesn't hurt to change them. Normally I wouldn't just shotgun caps, but we're literally talking about 3 caps. It's not that big of a deal, right? So we'll run with that. All right, here's what I came up with. These are 220 25s. Nichicon. They might have still been fine. Both of those were. But they're new now. I replaced them with 220 50s that I had. This one was a little bit of a problem. It was a 9,015. Well, 9,000's a little of a weird number. So I looked, I had some axials like this that were 18,000 that we put in Williams power supplies. That's a little bit of a jump. You're doubling the size of the cap. So I had some that were 15,000. So I put it in. 9,000, we're going up to 15,000. It's not usually a problem. It's just being used as a filter. So usually in a power supply you can get away with that. It may change the voltage, the output voltage a little bit. If it does, we have this adjustment here. So you can go up on it a little bit depending on the circumstance. So I did, because that's all I had. It'll be fine. I'll prove it here shortly. If it blows up any of these, you know, then you can laugh at me. But yeah, everything else looked fine. So I don't know. We're just gonna plug it in and see what we get. Now again, I've got the MPU board unplugged. I have the MPU board and the playfield unplugged and the cabinet unplugged. So the power cannot leave that power board. So since that's all since all of this stuff that's input, all it can do is burn up something on the power board. It can't burn up our MPU, which is valuable, you know. So the problem you would have is, let's say this thing's screwed up and it's sending out 12 volts instead of 5 volts. Every one of those chips that gets 5 volts would be directly connected to 12 volts instead, and it would fry the chip. And it would fry that one, and 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 that one. You know, it would literally fry every chip on the board. So that's why you want to isolate it when you're checking it. And that would not blow a fuse either. It's just, you know, it would just be a higher voltage. It wouldn't be a higher amperage. Okay, so I'm going to put this back in, and then we are ready to test the output of it. Okay, so the bridge rectifier that was messed up was this one. You can't see it because it's off the screen, but what it provides is the AC lamp's return and the DC lamp's power. I have no idea how in the world they're doing that, but that's what it says. Not the AC lamp's power, because that's AC, but the AC lamp's return, which I guess makes sense, and the DC lamp's power. So it's the lamps, basically. So one of the bridges is doing the lamps, one of the bridges is doing the flipper coils, I guess, and one of the bridges is doing the, I don't know about the 5 volt. All right, so yeah. It's the lamp bridge. That's all we need to know, which is typical. Whenever you have a problem on the valleys where the rectifier board, the bridge goes out, a lot of times it's the lamp bridge rectifier, because you got to think there's a lot of lamps on, so it draws more amperage. Okay, so we've got it all back in. I double, triple, quadruple checked. There's nothing else plugged in but the board. Now, you might wonder, why am I being so cautious? Well, I don't want to fry anything. This has been sitting a long time, and it's old tech. I mean, there's a right way and a wrong way to bring this stuff up so that you fry the least amount of stuff. I'm trying to do this live without getting killed. Get it? So you can see what happens when we plug it in case something crazy happens. All right, we're plugged in. Nothing appears to have happened. That is a power switch. I guess maybe they've got it turned off. I don't even know if I can reach it. Okay. So do you hear the transformer? And all of our LEDs are lit up. Save maybe that one. Let's see. That one's a little weak. It doesn't necessarily mean, though, that that voltage is missing. It could be that that LED's bad. I checked all of those fuses. They were all fine. Let's see what F2 even does. It actually says down there under it. Okay, so F1 is a 2 amp slow blow. That's the flipper coil group. F2, which is the one that is dimly lit, is the 9 ohm coil group. It's a 1.5 amp slow blow. F3 is a 1.5, I think it says, amp slow blow. That's the 11 ohm coil group. That's weird that they're naming how many ohms the coils are. Usually they don't do that. Oh, over here on the side it's telling us the voltages too. "40 volt, 40 volt, 40 volt, 40 volt." So F1, 2, 3, and 4 are all 40 volts. 6, 7, 8, and 9. Oh yeah, look how that says 7 volts AC and 7 volts DC. Crazy! F6, 8 amp slow blow. The AC lamps and 7 volt DC. Okay. F7, 2 amp slow blow. The LED displays, 6 volts. F8, 4 amp slow blow. DC lamps, 7 volts. F9, 4 amp slow blow. AC line, 115 volts. You know what I don't see? Is the 5 volts from the power supply. Okay, so I'm going to hook up the meter and see if I can test any of those. Sometimes you can test them right at the fuse on some games. I don't know about on this one, but we'll see. Okay, so I checked all of them. Every one of them's low, which is fine with me. I just don't want them to be high. You know, if they're high, they might burn something up. But if they're low, it just, at worst, something won't work. So like all of the 40 volt DC ones, if you look at the 4 fuses on the left, see how all 4 of the fuses are fed by that plane on the bottom of them there? That's because they're all the same voltage. So I checked at the top of each fuse, including the one with the bad LED, and they all measure 28 volts DC, not 40. So, you know, I'm not sure if that is actually supposed to operate at 40, especially with nothing plugged in. So I don't know. The AC lamps one tested high, actually. It was like 12 DC. I don't know what that's all about. Okay, the 6 volt one was like 4, the 7 volt one there was like 5, and then the 115 was 115. So they're all low, with the exception of that AC lamps one. So, a little concerned about that. But, you know what, I think I'm going to plug it in. Worst case, we'll burn up a bunch of lamps. I don't know for sure how they've got that. I guess I could look in the schematics and see how that even works. So, let's see if, you know, since I'm confused about it, let's see if we can figure out what. And I'm measuring it at the fuse, by the way, which doesn't necessarily mean that the voltage is correct there. So let me see on the schematics so we can figure out what F5 is even doing and why they're saying that it's AC and DC. All right, so I looked on the schematics. That voltage, where they're checking that, it's actually just AC the whole way. So I don't know why they're using it for the DC. I'm sure there's like some shortcut or electrical reason that works just fine. They're engineers, not me. But that's actually, you would test it as an AC voltage. So I was testing it as a DC voltage. And like I said, the other ones are low. So I'm going to go ahead and turn it on. The 5 volt was 4.98, which I was able to check right there on the side of the power supply. So that's going to be the voltage running the game board. Or I assume it is. I don't know. Maybe they're running it off 7 volts or something. It doesn't say anything about that on that little piece of paper down there. So I went ahead and plugged in the playfield and the cabinet. We're going to turn it on and just see what happens. There's no way in hell that board's going to boot. It's just been sitting in there probably since the mid-'80s, you know. So I'm going to turn it on, and then I'm going to turn it right back off if I hear any coils lock on. Didn't hear any coils lock on. I doubt that the board's doing anything. So these lamps are on. I'm sure, so these are the ones with the white and red wire and the white wire. So these are probably just general illumination stuff that's always on. So I would imagine our board is not booting, but I'd be wrong. Looks like it's booted. Crazy. Let me turn off the lights. See, now this is what I like. The thing's trying to cooperate. You know what I mean? It can tell that I want to help it, so it's doing its part. Okay, so that's the game over light, and it's flashing. So now if you're not familiar with the early solid state stuff, they typically did not have an attract mode, so none of the lights are moving around. But that's probably how it's designed. And it not telling you the high score, it probably didn't. So let's see if it will coin up or anything. Alright. So basically it has started a game, and you're hearing all that because something's stuck on the playfield. All these rubber rings are dried up. It's winning 3 games. I'm gonna turn it off. I like it. I'm gonna turn it back on. Now it could be too that once the game boots that there's some kind of stuck switch on the actual PCB or something, you know, so it could be something like that. But you know, folks, I gotta say that's a hell of a strong start to this little game. It wants to work. It's coming back. My displays look just fine. I'm just missing a flipper. So I think we'll end it there for tonight. On the next video, we might go ahead and do the playfield just so we can find that stuck switch, or if there's a stuck switch, and get it to where we can actually play it and mess around with it a little bit. And then we'll eventually work on the PCB a little bit if we find anything that's not working. So I am very excited about the progress so far. That's how I like to bring them up. It could have been we just turned it on and the thing worked, but remember the bridge was screwed up, so the lamps probably wouldn't have worked. Maybe just the controlled lamps on the playfield. But if something's been sitting a long time, I like going through the power supply, just making sure everything's cool before you turn it on, because you can cause a lot of damage to the PCBs if the power's too high. So leave your comments below. Let me know what you think. Now, if you like these weird games, I'll put up a video here of another weird one we worked on a while back. But we'll be back next time to work on this one a little farther and finally get to play it. Hope you enjoyed it.